Right, so this is a response to a video put out by Chris Chaput where he's talking about this truck concept he's drafting up. And I'm going to put a link to that in the description. But the crux of it is he's got this idea where he's put the axle onto this square indexer. The axle has two positions, and you can spin the indexer on four sides to get 8 different axle positions to test kind of back to back to kind of get some insight into the truck optimization and function. So Chris describes the purpose of this as to experiment with the rake as well as the distance to the kingpin.
It's basically made to answer the question, how does this thing ride with a lot of rake but close to the kingpin?
So what I want to do is take those terms, rake and distance to the kingpin, and replace them with 2 other terms which I feel are probably more useful and easier to understand for more people. So I'm going to start off by defining some features of the truck, and I'll start off with the pivot axis. On kingpin trucks, the pivot axis is defined by the center of the pivot and the center of the bushing seat. And the pivot axis is just a line that runs between these 2 points. There we go. Now in his video, what he calls rake, I like to refer to as axial offset. Technically, they're not exactly the same thing, depending on who you ask. But I like to avoid the term rake because, firstly, it's not descriptive by itself, and secondly, because it means different things in different disciplines. So I just would rather avoid using the term altogether and just say axial offset. An axial offset is the distance between the axle and the pivot axis at a 90-degree angle from the pivot axis. So that would end up being this distance right here. So because of that, any axle position along this line is going to have the same axial offset. If you put the axle here or here, same axial offset. So after the pivot angle, the axial offset is the next thing that has the biggest effect on the turny feel of the truck. And it's also the thing that predominantly accounts for the difference in feel between reverse kingpin trucks and traditional kingpin trucks. Because reverse kingpin trucks will have a very small or 0 axial offset, and traditional kingpin trucks tend to have a much larger axial offset. So whether you have the axle in this position, this position, this position, in either of the 8 positions, you're dealing with, you know, a range of axial offsets between here and here. And a reverse kingpin truck range will be more around, you know, here to here. The next thing I want to talk about isn't distance to the kingpin. I think that's a red herring. I do not think that the distance to the kingpin is mechanically all that important. So it is going to have some impact on the bushings, you know, how much of your weight is going into the hard pivot cup versus the soft bushing. And, you know, Chris made the fire trucks, so he knows all about how, you know, preloading the bottom bushing is going to affect the bushing responsiveness and all that. So it is going to have an effect on that, but just purely mechanically, it's not going to be doing very much. The thing that's of more mechanical significance is actually the roll center. And the roll center is the distance from the axle vertically to the pivot axis. So right there. So on this truck, the roll axis is right here. And basically what the roll axis is that's the position where the deck is leaning around. So if this ruler is your deck and you're pivoting like this, the roll axis is the center of the pen. But if it's rolling like this, the roll axis is the center of the tape, and that distance is what's important. So basically, as you move the axle forward close to the kingpin, what you're doing, if you put it all the way over here, you're bringing the roll axis all the way up there. And what that's doing is it's, what's important is, of course, the distance from your feet to the roll axis. This is the important distance here. So you're adding to that distance there. So there's other ways you can add to that distance, and that's with a riser. This is starting to get really messy, but let's say this axle height corresponds with this deck height. This axle height corresponds with this deck height, and this axle height corresponds with this deck height. So this is 1, 1, 2, 2, 3, 3, right? I would put it to you that these three axle positions should turn and behave very, very, very similarly, almost indistinguishable, aside from the effect that it's going to have on the compression of the bushing. So I'm really interested to see whether the experiment Chris is doing with his truck, once he makes it, is able to repeat the results that I've predicted on paper. And if it does, then that's really good for my model and my understanding for how trucks work. If it doesn't, that means that there's something going on that I'm not accounting for, and I'd be really interested to see what happens either way. So there we go. Hopefully this paper didn't get too messy, and I was able to walk you through that without you losing track of what was going on. If you haven't already, go ahead and watch Chris's video. If you've made it all the way to the end of this one, then I'm sure you will enjoy his, and I'll put it into the end cards. So there we go. Longboard technology, over and out.